Good afternoon, everyone. Let's start with this map so we can all know where we are coming from. So I will give you the permission. So Bruno and I are both forecasters at the Portuguese Met Service. I will talk about the current weather situation, and Bruno will talk about some recent events. So on your left side, you can see the weather forecast for Portugal, mainland Portugal. Some showers. Lisbon, maybe only cloudy sky or a chance of showers. And the maximum temperature for today will be 26 degrees. Thank you so much, and we will continue. So let's start with an overview using the upper levels. As you know, the water vapor channel can give information about upper air dynamics. So for example, the position of the jet stream, but also the moisture and dry boundaries that can be areas of convection initiation. And of course, some dry areas are very important because they can be dry descending stratospheric air with high potential vorticity, so potential for cyclogenesis and rapid cyclogenesis. So I overlaid here with the 300 geopotential and isotax, so it will be easier to identify the features. So as you can see, the jet stream is located further north, but is moving southeast, surrounding this trough over Western Europe. This will be a cutoff low in the next 24 hours, so western of Iberia. We also have a shortwave trough, a shortwave here over Morocco and Iberia. It's a shortwave trough that has been moving eastward, and since yesterday, and there have been some deep convection over so Western Mediterranean, Spain, and also Portugal. Some of these convection were initiated in the afternoon hours yesterday, but there are also several short waves troughs along the east, along the south parts of Europe. You have one here over Italy. You have another one further east, and you also have this one, Southeast Europe, Eastern Europe, and of course you can see here a low pressure system with the jet stream affecting further east. Also, we can have this, you can see here over Central Europe, the upper level reach, and another one over the Western Atlantic and on south of Northern Africa, so south of Europe. And of course, we also have here an interesting feature that you can see southwest of Azores. This is the tropical cyclone Margot, and the future path towards Europe has been quite challenging. I will talk more about it later. With this RGB, you know, Airmass RGB, we can identify the areas of warm air mass and cold air mass. Also, I have here overlaid the mean sea level pressure, so it's important to see the main centers that we have here, the low pressure systems and high pressure systems. So warm air mass, you know, it's the greenish colors you can see almost dominating over southern Europe. This warm air, it will be advected north, affecting also British Isles and Denmark. We also have have some cold air, of course. So you remember cold air mass, it will be bluish color. So we can see over the Atlantic behind this frontal system that is from northwest Iberia towards Sweden. We have here some bluish color, so the cold air mass, also some cold air mass it's advecting from north, surrounding this high pressure system over Central Europe. In fact, this high pressure system, both these high pressure systems, so this one and this one, will be they will have an important role in this weekend, in the next hours. Because this one is blocking the movement of Margot, and this one is also almost stationary. So the frontal system will go further north, and the activity with some convection will stay further south. Of course, we have here some areas of interest. So in the next hours and in the next weekend. So we have here in over Iberia, we are going to have convection, heavy rain in today and tomorrow. The cold front that is attached to this low pressure system is moving towards Iberia and affecting all this region. This frontal system over British Isles will affect Ireland today with yellow and orange rain, warnings for rain, and of course also Italy, Adriatic and southeastern Europe. As I mentioned, the shortwave troughs will bring some convection over this area in the next few hours. Of course, we also have the tropical storm Margot that is affecting Azores, and it will continue in the next day and weekend. In case also, I want to add about these systems, not only the tropical cyclone Margot, but this system over northwestern Iberia. They are generating high winds in this area, so they will generate high seas that may affect land in the next day. So also some coastal areas, France and Iberia, will have to pay attention for these high seas that are approaching this region, and of course the high seas generating from tropical storm Margot. So this is the surface levels. Like you can see, this is night microphysics RGB on the left and the natural color on the right. And it's interesting to find that there are many areas that are related to the high pressure system with clear skies, but also some patches of fog and very low clouds. You can see here in Poland, South Germany, but also in Iceland. We can see these patches of low-level clouds. Of course, the thick cloudiness, the frontal cloudiness that's going from northwestern Iberia towards Sweden, the spiral cyclone that you can see here northwest of Norway, it's bringing some weather from this for these areas, and of course the convection that I mentioned before over the Adriatic, Iberia, and east and southeastern Europe, and another frontal system that you can still see further east in this left part of the image. Over south of Greenland, so on the other side, you can see big frontal system that is moving east, northeast, and will affect Iceland during the weekend. We also have some spiral, so you can see some convection cloudiness south of Azores, and these are some spiral rain bands that are detached from the tropical storm, and they have been affecting the area, and so we have yellow and orange warnings for rain in these islands, and also many warnings again south of Europe regarding thunderstorms, and Ireland for rain because of this frontal system that is approaching. So some areas of interest for the next hours. So in the Atlantic, the tropical season is at its climatological peak in September, and these are the current tropical cyclones and one disturbance. So Hurricane Lee and Tropical Storm Margot are both active. So Hurricane Lee is now category 1, which is the strongest, and this hurricane is the strongest of the year so far. He reached category 5 some days ago, and is moving towards north and northeast, affecting United States and Canada coastal areas. And later next week, it will reach northwestern Europe. So Margot just became a tropical storm. So when I was preparing this presentation, Margot was still an hurricane when I started preparing this presentation. And then after some hours, Margot was already a tropical storm. So it weakened during the night. It now will move east and southeast, and is forecast to make a clockwise. And you can see the movement, the clockwise movement here in the next days, because as I said, the blocking ridge is building over in North Atlantic. So it will stay more or less in this area for the weekend. At this moment, it's not clear if Margot will be caught in the westerlies or stay further south and continues to meander over Central Atlantic. So we still are not sure about the future of the forecast for Margot near Europe. So it will stay for the weekend in this region, and let's see what happens in the middle of the next week. So of course, we have the ABI from Goes East. Of course, he also saw Hurricane Margot. This is Cloud Phase RGB. This is a proxy image for the new FCI on MTG. This new RGB will be available in the future, and as you can see from the recipe in the upper right corner, it can only be used in daytime, and the new channel that will be available with the FCI sensor is the near infrared 2.2, and here is assigned to the green beam. So this new RGB will have this new channel assigned to the green beam. So near infrared 2.2 is very good. Why do we have it here? Is because it's very good at discriminating cloud particle size. And the new near infrared 1.6 is very good at discriminating cloud phase, so different microphysical characteristics. So that's the main reason that they are used together. Let's make a zoom here over this was yesterday. This image is from yesterday. So yesterday was still a hurricane. So let's make a zoom near the area. You can see Azores Island here. And here we have some examples from this image. Mainly the blue shades represent thick ice clouds, and we have the large particles will be medium blue and the small particles will be light blue. Just to get familiar with these colors and get familiar with this new RGB. So some examples, we have the bluish for the thick ice clouds, and we have the magenta colors for mainly for the thick water clouds. And of course, again, with the difference of large or small droplets. This example, you see, it's dark magenta maybe, and if you have dark magenta, maybe this is also a mixed phase cloud. So it's the difference. But if you have pink, it could be thick water clouds with large droplets. If you have a little more yellowish, they are smaller droplets. So these are some more information about this new RGB. So as you can see at the red beam, the information is more about cloud phase, the green beam about cloud top particle size, and the blue beam about cloud optical thickness. So this is important. Also some limitations. One of them I have already said. You can only use it during daytime. There is no temperature information, so this is a limitation when you are monitoring convection, and very thin water and ice clouds are still a problem, so not easy to discriminate. If you want to know more about this new RGB, you can go to the EUMeTrain webpage. There is the RGB quick guide, but also the new extended guide to the Cloud Phase RGB that is very new to the EUMeTrain webpage resources. And of course, you have here the typical colors. In this case, is the from VIR's instrument, Cloud Phase RGB, but in the future from FCI, they won't be that different. And just to end my presentations, this is the ECMWF0 UTC forecast for Margot. On the left side, you have the 14 September, and on the right side, you have the 15 September, and bottom also 15 September. But all of them are zero UTC run. And you can see we still have a big spread in the long range. So we still don't know if Margot will go further northwest, affecting mainly UK, Ireland, France, or if it goes east and affecting Iberia, even Madeira is possible. So it has been like this for several days. We're not sure about the movement of the reach, the way that if Margot will be caught up by the westerlies. So we still have at least until the weekends and the early week, we don't know what is going to happen to Margot. So we will see. So that's all from my side. Thank you for your attention. And now Bruno will continue.
Hi, hello, good afternoon. So I'm Bruno. I work as a marine and general forecaster at IPMA. So I'll start with the 5th of September. We had an omega block pattern influencing the weather in Europe. On the east side, we can see over the Atlantic Ocean an interaction between ex-Hurricane Franklin and near stationary low with expression on the higher levels of the troposphere. On the east side, over the Ionian Sea, a stationary cutoff low named Storm Daniel. And in Central Europe, we had a blocking ridge, and this ridge would be responsible for some record-breaking temperatures for September in UK, France, and Netherlands at least. And it combined the advection of warm air on the western flank of the ridge and the subsidence provided by the anticyclonic feature. Looking at HRV RGB, it's easy to identify the Hurricane Franklin over the ocean and Storm Daniel over the Mediterranean. And you have here the absence of clouds over Central Europe and indicating the presence of the blocking anticyclone. In early September, there was a lot of cyclonic features over the Atlantic. Hurricane Franklin would merge with tropical storm José and then head east, interacting with the stationary low west of Portugal. And as a post-tropical storm and always on the brink of acquiring tropical characteristics, Franklin would still generate winds and waves over the ice seas in the Portuguese area of sea forecasting and vigilance. So we'll look at some scatterometer and altimeter data used to track the cyclone and validate marine forecasting warnings. Here is just a brief reminder for those who are less familiarized with scatterometers. So it's a microwave radar instrument. It detects the backscattered signals that it transmits, and then it derives wind speed and direction over water by measuring the roughness of the water. It has some problems with when the winds are very strong, like above 60 knots, and has a near global coverage. And we use a lot METOP B and METOP C with the sensors ASCAT. Here you can see the ASCAT C swap on the left at around 11 p.m. and on the right superimposed on the 12 UTC natural RGB. And it's easy to see Franklin center of the low near the surface and clearly showing the cyclonic circulation. And the highest winds measured by the scatterometer range from 30 to 35 knots, so approaching the maximum sustained winds attributed to a tropical storm. And so we had a gale warning issued for the ice seas. Looking also for a brief characterization of the altimeters and some of the most used nowadays. So an altimeter measures sea surface height, wind speed, but more significant wave height, also by sending a microwave pulse. It has a very good accuracy, and we use mainly the Sentinel 3A, 3B satellites and JSON-3 satellites, also Cryosat 2. Here we have a collection of some satellites passing near Azores Islands between 0 and 12 UTC of the 5th of September. The Cryosat SWAT passage is over or near the zone of the highest waves generated by Franklin cyclone. We have 6 meters of significant wave height detected by the altimeter north of Azores, where the arrow is, and at around 5 UTC. And then we have some other passages of satellite that are passing further away from the zone that they were not so useful in this situation. Looking at a collection between 12 and 24 UTC of the same day, the Cryosat 2 passage is a little more to the east than the earliest one, but it also detects 6 meters of significant wave height north near the Azores Islands at around 17 UTC, and the other altimeters are passing also further away from that zone in this time period. Here we have a SWAT from the Sentinel 3B passing near Azores Islands at around 13 UTC. And then on the right, we have a comparison between the 12 UTC step of the SEMWF model. There were around 5.5 meters of significant wave height detected by the altimeter northwest from the western group of the Azores, and it was pretty consistent with the closest step of the SEMWF wave model. We can see here in this graphic the red data for SEMWF and the blue for the Sentinel data, and they are very consistent. So an heavy waves warning was issued for that area over the ice seas for waves higher than 5 meters. On the same day, and looking at the altimeter data over the Ionian Sea, the SWAT the swath don't pass exactly over the storm Daniel, but detected 30 knots of wind west from the center of the storm. So this is Storm Daniel, and it was the fourth storm of the 22-23 season, named by the Eastern Mediterranean Group, which comprises Greece, Cyprus, and Israel Meteo Services. And it was issued the naming at the 4th of this September due to the forecast of heavy precipitation and red level warning event. Here the next RGBs are a sequence of the images for the 5th of September. We have the night macrophysics and the natural color. Of the many features we can observe in these images, there are thick ice clouds associated with Daniel, either reddish brown in the night macrophysics, and thick mid-level clouds more to the south. We have some also low clouds over the north of Italy, also visible in the night macrophysics and the natural color. And then we have some dust clouds over Spain, France, the Western Mediterranean, also visible on the two RGBs, also over Algeria and Tunisia, and of course you can also use the dust RGB, but mainly using these two RGBs, we can also see the dust over here. On this second frame, thick clouds in cyan color related to the storm Daniel. It's easier to see in this natural color RGB. We have the low clouds over the northern Italy dissipating from southeast to northwest when exposed to solar radiation in the direction of dry winds from the east, and the dust clouds in the seem to disappear on the natural RGB. They are there, but they don't show. If you look at to the next hours, dust cloud appears on the natural RGB at the latest hours of the day. This is due to the position of the satellite relative to the sun. So at dusk and dawn, when the angle is wider between them, there is mist scattering is detected by the bands of the natural RGB, and you can easily see the dust. And this is particularly true or helpful when situations with small amounts of dust in the air. The low clouds over Italy almost completely dissipated over northern Italy, and the thick ice clouds persist over Greece. Here we can see two weather stations located at or near the Pelion mountain in Greece. In the afternoon, they had already registered over 600 millimeters in 24 hours. And the Zagora station, the one on the left, would eventually set a new record of 754 millimeters in 24 hours. And just to have a reference, it's the equivalent of more or less 1.5 years of rain for that region concentrated in one day. Here we have the before and after the event. So through the True Color RGB from MODIS, which uses bands that better mimic what our eyes can see, we can see that northwest of the Pelion mountain, the large dirt colored flood regions, and also dirt and debris flowing into the Aegean Sea. Just to see the high contrast in weather events in a short period of time, around 15 days before, Greece was experiencing high temperatures, dry air, strong winds, leading to an outbreak of big fires that led to extensive burnt areas. I will now permit you the annotation to see if you can point out the burnt area showing in the 21st of August image. You can compare it with the 17th of August. It's a pretty small area. This is the false color RGB, which is these bands that in combination are very well suited to see the contrast between vegetated and non-vegetated areas. This little area here. So you can see the big contrast between vegetated and non-vegetated areas. here you can see the smoke plumes through the True Color RGB from Terra Modi satellite for the day after, and for a bigger fire in the same region, we are seeing that burn area. And if you look at here, the before and after images we already saw, and then the next one. So this is, we can see clearly the bigger burned area after the 21st of August here. So it was like on the first fire, a smaller area, and then a very extensive area after those fires persisted in this region. So now, ending up several days after, in the 10th and 11th of September, Storm Daniel, also fueled by the seawater temperature near the coast of Libya, would generate extreme rainfall and consequently severe flooding in the country that led to the collapse of 2 aging dams and heavy loss of lives and livelihoods. And here you can see the SST over 26 degrees near the coast of Libya, obtained through the NASA State of the Ocean site. It uses several instruments among MODIS and AVHR, has a 1 kilometer resolution and this daily temporal resolution. And here's the before and after, and this is the HRV. So because water is a weak reflector of solar radiation, it's clearly visible, the flood areas in this 12th of September after this event. So thank you for your presence. Next weather briefing will be on 25th of October.